How you doing today? My name is Joshua Ruderman. Let's get into these problems here. Today we're going to be multiplying radicals or square roots. Before we get into this problem, you should have watched my previous videos on simplifying radicals or simplifying radical expressions and working on that kind of stuff because it is valuable. There's a lot of it in Algebra 1 and Algebra 2, and it's just one of those skills that you're going to need if you're going to keep progressing through math. Let's start with this guy here. As always, I have my problems listed over here, so if you want, jump ahead, see what you get. Pause the video, try them, okay? You're probably gonna get a lot more out of these if you try these things, do the work, and then come back and see how I did it and like kind of match up your work with mine. Again, I'm always gonna take like the most extensive route through these. Yeah, there's shortcuts through a lot of this stuff, but this is not shortcut math, okay? It's just practical math. It's math that you will be able to do by following these steps. So I don't want to encourage shortcuts. Maybe I'll do some lessons where I teach them, but that's not how you should be initially learning your work, okay? Just my little public service announcement. Let's get into this one here. Square root of 2. I'm going to write these really big if I can. And square root of 8. Notice I'm going to make my multiplication signs a lot of the times. That's kind of awful, but I'm going to make them kind of like these asterisks just because as you get into this kind of work, and I've said this before, you're going to have decimal points, you're going to have dots in between parts of problems and stuff, and this just makes it very obvious, at least as I'm teaching it, that this is a multiply sign. And if I put it in as an x, then maybe it looks like it's the square root of x, square root of 8. It doesn't always work too well. When we're multiplying these, there's different ways to do this. And so I thought, I'll kind of give you two different methods here, okay? We could do square root of 2 times square root of 8. Here, actually, let me just rewrite them here, okay? Because there are a couple different ways, and I don't want to just show you one way if I can show you others that will work as well. So over here we got square root of 2 times square root of 8. Well, we could just multiply straight across. Square root of 2 times square root of 8 is the square root of 16, okay? And then maybe you notice, oh yeah, square root of 16. 16 is a perfect square, right? And again, you can check these in your calculator if you're not sure. But we could just notice that 16 is a perfect square. Therefore, the square root of 16 is just 4, okay? Using the simplifying radical expressions kind of method, which I've done before, where you pull out the doubles. This one, well, it's a prime factor, so we can't do anything. But this guy we can split into a square root 2 square root 4. Now I know you might be saying, well, Josh, dude, square root of 4 is 2, so can I just put that out? Yes, you can. But I'm going to go to the nth degree and keep square rooting this thing, okay? And the way I always phrase it with my students is when you have a double, when you have something that's 2, okay? Like right here we have 2 square roots of 2. We've already kind of talked about this in the previous lesson, so I don't want to go over it too much again, but when you have a square root of 2 times a square root of 2, or a square root of a number times the square root of itself, then the square roots kind of cancel out. And you can try it on a calculator too, and I encourage students to do that so that they realize that square root of 10 times the square root of 10 is just 10. As long as you don't like take out all the extra numbers that go on your calculator, you should end up with 10. So when I say pull that out from underneath, well, I consider this kind of like the square root sign is like what it's under. So when I say pull out your doubles, that's what I'm referring to. So you're going to take a double here and you're going to pull it out from underneath the square root sign and just write it as a 2. And we have another double here, so we're just going to pull it out from underneath the square root sign and write it as a 2. Okay, so hopefully this part makes sense as to how I pulled these out. I did have those other videos on simplifying, so if you're not sure, maybe check that one out as well. And when I pull these numbers out, right, just like a long time ago when you made your factor tree and you had 12 and you did 6 and 2 and 3 and 2, right, these are all factors, okay? And factoring means that, or what you should be thinking of, is that when you have factors of a number, it means that all of these numbers can be multiplied together to create that top number that you have, okay? And when you do these in a calculator, you should be able to get to this point to where you can do square root of 16 and get a 4, or just know that you could pull out your doubles, get a 2 and a 2 as your factors, multiply them together, and get a 4, okay? And so when it comes to just a square root and a square root, there's 2 ways you can do it. You can multiply them together to get some big grande number and then square root that thing if you can. Or you can work on it piece by piece like this and just kind of make factor trees for both of them. And so if this was like a 6, I don't know, a 12 or something, right? You could factor that guy down and factor down your 8 and then take all of your doubles and start pulling them out. And just like in my simplifying video, when it comes to anything that's left, like let's say you still have, after factoring this number and you factor this number, you pulled out all your doubles, multiply them to get some big number. Anything that's left, like let's say there's like a square root of 3 and a square root of 5 over on this side, you just multiply them back together and put them back underneath the square root sign. So you would end up with some big number here, square root, and like I said, if you had a square root of 3 that was still left and a square root of 5 that was still left with like this other number you were given, then you would just make that a square root of 15 underneath. Okay, because you can't do anything with it. I guess technically you could write it as some big number, square root 3 times square root of 5, but then they're just gonna say, well, dude, why don't you just multiply these two together and just put it back under the square root sign, okay? And it's possible maybe this number here is gonna cancel out with, maybe this is part of a bigger problem. There's something on the bottom part of this in the denominator section where it's like 3 square root 15 or something, and you can cancel these out, maybe there's something that you can do with it. That's for another lesson. So let's move on to this next problem here. Like I said, if you want to get this, try this one, move ahead a little bit, try these out, see what you can do. If you can jam through these, then I don't know, I guess you kind of don't need this video. All right, let me write this thing down. At the least though, I would watch and just see what I get as my answer. Okay, so this is the same thing. Now they start to look really complicated, but just, don't let that bother you, okay? This is the same thing as like 3 times like x plus 4, right? We just distribute, we do our rainbow, and we distribute the 3 to both items, right? So this would give us 3x plus 12. Cool? All right. So using this, we can apply it to this. And let me just draw my little rainbows. Again, I'm always going to do the extra stuff to remind myself so that I don't make mistakes. Let's see here. What do we got? A 5 times the square root of 2 is going to give me a 5 square root 2. Can't really do much with it, but that's okay. And we have a square root of 2 times negative 3. So I'm going to get negative 3 square root 2. Okay? Actually, let's see. Oh, that's a square root of 3. My bad. Let me change that. See? Even teachers make little mistakes. Too busy talking, I guess. Square root of 2 times the square root of 3 is going to give me the square root of 6. Okay? And at this point, can I combine like terms? No, I can't really do anything. So at this point, for a problem like this, that's your answer. Now, I'm hoping you're not saying, yeah, but Josh, dude, like, why did you just give me a problem that like I couldn't combine like terms? I couldn't do anything with it. And honestly, the main reason is that the book or the teacher or whatever, they just want you to understand that there's rules that we're gonna apply to problems like this. And so they're just trying to get you into that mode of, well, what do I do when I have something inside and outside the parentheses? And how do I work through it? Okay, so the point of the lesson is really to just, for this part, for you just to understand how to distribute the square root sign. And, if you can't combine like terms, that's okay, because maybe this is like one small piece to like some big old problem out here or something, right? We don't know. Okay, so let me erase this guy and move on to the next. 1 plus square root 5. 1 plus square root 5 squared, okay? The reason I chose this problem is because as you're learning this, students get ambitious and they start going crazy, right? what I mean by that is they go, oh, there's a square root of 2 up here. I'm just going to distribute that to both of these, right? So I'm going to get 1 squared plus, well, square root of 5 squared is just 5. 1 squared is 1. So my answer is just 6, right? Not really, okay? The rules of math apply. You got to be careful how you're doing this kind of stuff, all right? What you need to do is you need to say, no, this is not correct. What I need to do is understand that this 2 up here is an exponent, right? So if I have 4 squared, that means that it's a 4 times a 4, right? My exponent tells me how many there are, and my base unit here is what I use for the bottom values. So we have to apply that to this, right? This is a quantity. This is like a group package deal here, and we can't just start busting things into smaller parts like that. Now, in some ways you can, but with binomials, you really can't. Okay, so we have to look at this like this. 1 plus square root of 5 times 1 plus square root 5. And now we can use that method and just FOIL this thing. And then combine like terms, and we should be done. So let's see what we get. First is going to be 1 times 1 is just a 1. Let's see here. Outside is going to be a 1 square root 5, or we could just say plus square root of 5. Inside plus square root of 5. And then we have square root of 5 times the square root of 5. Well, we already talked about that with the earlier problem, right? The same unit underneath, or the same value underneath, is going to cause it to just lose the square root sign. So square root of 5 times the square root of 5 is just 5. Cool. Can we combine like terms? Heck yeah. Let's see here. We got a 1 and a 5. That's going to get us a 6. And then we have square root of 5 plus the square root of 5 is going to be 2 square root 5s. Okay? The reason it isn't canceling out or anything is because we're adding. And so, you know, when I'm in class with students, there are times when I'll actually write in that 1 right there, just to kind of remind them and me that this is 1 square root 5 plus 1 square root 5 is 2 square root 5. And sometimes I'll even go even back further and say, well, what if this was just an A, right? An A plus an A is not going to give me, you know, I'm not going to be able to like square them or anything. It's not A squared, it's just 2A. Okay, so if I just have values here, if these were x's, it would be 1x plus 1x is 2x. So 1 root 5 plus 1 root 5 is just going to be 2 square root 5. And at that point, I'm going to look and see. Now, some students are going to say, hey, dude, can I combine like terms again? 6 plus 2, right? They're numbers. Well, you can't. Okay, the reason that you can't is because this guy is technically attached to that little guy, the square root. Okay, so we can't just start combining numbers just because we see them on the outside of the square root sign. We have to take a second and realize this is 2 times the square root of 5. It's not the same. If we were to try it, if we did 6 plus 2 and got an 8, and then timesed it by square root of 5, we're going to get some crazy answer. That's definitely going to be different than if we did 2 times square root of 5 equals and get some number, and then do 6 plus that number. It's going to be a different answer from what we get here. Okay, so we just have to be careful that we don't go too crazy when it comes to combining like terms, and we be aware that these square root signs are parts of this number. Okay, this is kind of like a package deal right there. All right, so maybe you've made it to that last one. If you've seen that one before, don't give it away, but hopefully you worked through it and you saw what was going to happen. A minus square root of b, and then we got a plus square root b. Okay, these are interesting. Okay, because one of them is a minus and one of them is a plus, or one is a plus and one is a minus, they're kind of like opposites each other. Opposites, I guess I should say. And there's a technical term for that in math. I know, more vocabulary. Dang. Technically, they're called conjugates. Conjugates. Yes, that's right. conjugates, okay? It's when you have one of them that's a minus and one of them that's a plus. And certain things happen when you multiply these types of problems. Now, if you've been doing a lot of the other stuff in like an Algebra 1 class, then you've seen this happen when you have like x plus 3, x minus 3, right? Certain things happen when you FOIL this type of problem. So if you remember what to do here, it's pretty much the same thing here. But now we have square roots, so we just need to make sure we take that into account when we do our multiplying. So let's just, if you want, you can write out the letters. I sometimes do, it's up to you. A times A is gonna be A squared. Let's see here, outside is gonna be A times square root of B is gonna be a plus A square root B. Inside is gonna be a minus A square root B. And then we have a negative square root of B times a positive square root B. Well, a negative times a positive is gonna be negative. Square root of B times the square root of B is going to be just B, right? Because the square root signs are going to cancel. We already talked about that in a couple other problems here, so just make sure you're starting to understand these rules we need to use. Let's see here, plus AB minus AB, or square root, whatever, those are going to zero out. And so we are kind of done. We have A squared minus B as our final answer. And that's as far as we can go, okay? So let's just keep this in mind. Conjugates are gonna become important, especially when it comes to simplifying certain types of radicals. I'm gonna make that into another video just so that I start to separate out some of these terms. A lot of this stuff kind of blends together, but if you just wanna kind of move your way through all these videos, it should all start to make sense. So thanks for watching. I'll be seeing you around.